Here we have another example, and we want to identify, this is a graph of f of x. We want to identify which values of c does this exist. Okay, where does this exist? Okay, well, in here you have a nice continuous curve everywhere. Wherever it's continuous, you don't have any questions. It does exist, wherever you have a point. Now, there are some trouble spots here. This one, it's x equals 0 here, because at x equals 0, you have a break. So this break in here, where it jumps from this point down to this point, for that value of c, in other words, we could state it, the limit x goes to 0 of f of x does not exist. Okay, because of that jump. Now there's another problem over here, and I'm going to assume that that's -1 for the x value. That limit doesn't exist either, because the function value looks like it's a -2 here. This looks like -2, but the function itself is heading down this way, either side of that -1. So another place we have a problem is at -1. This also does not exist. Okay, it does not exist. Let's see, any others here? On this one here, we have a hole in the graph, and on either side, function is getting closer and closer to this value here, which is a 4. So it looks like from our graph that the limit as x approaches -4 for f of x actually does equal a 4. So it exists, even though you see there's a hole here and the point drops down. So it is defined also. Notice that for this value, we also see that f of -4 equals 4. I'm sorry, 0. Let's do that. That's a 0, so pardon me. Okay. So, so then we have the 3 places where it doesn't exist. That means it exists everywhere else. We can find this heads off indefinitely in that direction. So it exists everywhere else except for these points that we found. -4, x equals 0, and x equals -1. So we have problems there. So everywhere where the function is defined, we have limits except at those points that I've listed here. Okay. All right, here's another example, and we want to find this limit as x approaches 2 for the function. Now we have a nice graph here. You could see this piecewise defined functions graphed over here. And you can see that as x gets close to 2, the function is coming in along here or along here. And it's heading to that number. And see the height here. So you can see that that value here, the y value is 2, 4, 6. So in other words, that ordered pair, if it were right there, the y coordinate would be a 6. But those are the coordinates of the whole. We'd have 2, 6. So that tells us that the limit as x is approaching 2 for the function f of x as defined here actually is equal to 6. Even though, notice that the function value itself is a 4 down here, right there. So the point for this function is 2, 4. But the limit as x approaches 2 is a 6. So you can have a discontinuity at a point, still have a limit.